Hello, today I'm going to demonstrate using the Pincoder adapter on a Williams System 7 board. We're going to be doing the first test, which is the O1A LEDs test. I will show you the test running. I will also show you how to use a logic probe to backtrack the signal path to find out where you might have a problem if you have a problem. The first thing we're going to do is remove the green ROMs, the game ROMs, and the RAM because we do not need them for this test. I'm going to use an IC puller. I like to take these off and put these on a piece of anti-static foam in the order they came off because that helps eliminate any issues. We're going to put them on. I would like to point out that this chip says IC20. It is actually IC17. IC17 and IC20 are mislabeled for some reason on this game. I should point out this is a known working board, and that's how I know that those are mislabeled. And then finally the RAM. The chip puller is too big for that, so I'm just going to use a little pick here. A little lower pressure. You can see the socket's already been replaced. Okay, so the components we're going to be looking at is IC1, IC8, PIA1, which is also IC18. We'll also be looking at these pads here, which is where the LEDs would be if this board had LEDs and not a 7-segment LED. We'll also be hooking our logic probe up to C23 here. This is the negative end, this is the 5-volt end, and it's a very convenient place to hook up your logic probe. And then we have our power connected here on, this is 1J2. I am using a very simple Elenco LP-900 logic probe. This was probably $12. And also using a Meanwell RQ50B power supply. It's a switching power supply that outputs 5-volt, 12-volt, which is exactly what I need to power this board. So here's the Pincoder adapter, version 2020-0623. Notice I have multiple layers of sockets on the bottom of that. This board has a crystal right here, which impedes the area of this adapter. So by putting it on these sockets, you can get that past it. Okay, so I'm going to turn on the power supply and you'll be able to see a successful test. You can see the LED here is going 0 through 9 and then starting over again. That's great. But what if that wasn't working? I'm going to take this and we'll connect it here to ground and here to 5-volt. And then what we'll be looking at is initially for boards prior to System 7, it had 2 LEDs here. And what the tests would do is they would flash between the 2 LEDs. And you can see high-low there is the LED turning on and off. Now to really show the board is running, it would cycle between the 2 LEDs, the upper lower. That way you could see a difference that something was running and it wasn't just an accidental flashing. So what we're going to do now is we're going to backtrack. So say this LED wasn't working. So we go to PIA1, which is IC18 here. The first thing we're going to look at is pin 39, and we're going to see that that is stuck high. That is what we expect. Next, we're going to look at pins 6 and 7. 6 ties to this pad here, and 7 ties to that pad there. So we should see those cycling the way we saw the pad cycling. There we go. And you can see it pauses when it hits 0. All right, let's look at 7. It's a more even cycling there. All right, now we're going to jump back to IC8. Pins 14 and 13 are commanding the PIA to operate that way, but they're just slightly pulsing. That's 14, that's 13, and we have pin 3, which is being driven by the CPU, and you can see that that guy is pulsing very quickly. So here on IC1, pin 5, that is the data pin that is driving, and you can see it is pulsing just as fast as IC8 pin 3 was receiving it. So that is a successful test of the Pincoder adapter on a Williams System 7 running 01A LEDs on a System 7 board. Thank you.